So welcome everyone. Thanks for being here. Thank you to another training session from the Network of Resources webinar series. So if you're joining us for the very first time, this is a webinar series that is organized as part of the Network of Resources initiative, which is an ESA initiative that aims at promoting the use of cloud resources and platforms and services for Earth observation data exploitation. So the NOR, or the Network of Resources, has this portfolio of services that are brought to the users by operational cloud providers that give access to their data, services, and resources and platforms, and help the users to work with the data, build their workflows and applications. And the NOR specifically supports building educational, scientific, and pre-commercial applications. So within the NOR initiative, we have a sponsorship process that allows you to try these different services. So I'm here today with my colleague Federico, who will present you the NOR portal and the sponsorship process at the end of the presentation. And today we're very happy to have Antonio and Simone, who are going to present to us the Advanced Geospatial Data Management Platform, or ADAM platform, that is operated by Mayo. So I will hand it over to you, Antonio. And please, to the participants, write to us your questions in the chat. We will take them at the very end of the presentation, as usual. And right after that, Federico will present you the NOR portal and the sponsorship process to request a sponsorship to use these services. So to you, Antonio.
Okay, so hi everyone. I am Antonio Veccoli. I'm the head of user support and training unit at Mio. And first of all, I thank Zaida and the NOR for this opportunity. What I'm presenting today is our main core technology, the Advanced Geospatial Data Management Platform, better known as ADAM. First, just a small introduction. ADAM has been designed, let's say, to face some of the most challenging, let's say, issues or problems or critical points that the EO community meets while using geospatial data. We know that nowadays the amount of geospatial data that made available by public or private entities is constantly increasing. This because there are not all these data provided by satellite missions, but we can also talk about models, for example, for weather or atmospherical forecasts or in situ data, or nowadays we also see geospatial data produced by the usage of drones. So we have a lot of data to use, and it is not the amount of data the real issue. The actual problem is that the geospatial data provided with a large variety of formats and technical specifics, and for the users, this is say an obstacle to an efficient exploitation of the data, especially when they want to use the data on a massive scale. This is where the concept of ADAM comes out. ADAMs provide a multi-resolution and representation of the planet, where the user can find, visualize, and make sense of vast amounts of georeference information, navigating, let's say, the globe and navigating the virtual planet on the spatial dimensions, on the temporal dimension, and of course through the data layers that are provided in the platform. The ADAM platform does not provide products that are made by itself, but ADAM is connected to the biggest existing data facilities, and it allows the users to get the data, to access the data from these providers without needing to log into each of these providers, just logging in and just getting a single account to the ADAM platform. As we will see later, ADAMs provide multiple ways to get in touch with the data, to use the data, and there will be three main types of user interface that are let's say, designed for different needs, even for different kind of users. Here you see a quick, let's say, an overview of the Adam ecosystem, and it's a modular architecture that is composed by three main elements. There is a data layer where you can see the, let's say, the list of data providers that where the data access takes the data, and the data are then, let's say, put in touch with the processing layer. It is in the processing layer that we can get the data with the specific features of Adam. For example, extracting subsets from the original product with a native resolution, or extracting time series at the pixel level. On top of these two layers, there is a user interface layer that, let's say, manage the activities between the two other layers. And on the very top of the structure, we have an authorization accounting unit that not only manages, let's say, the registration of the users, but also allows the creation of groups of users. So group of users that can need just a subset of the full catalog, and it also manages the, let's say, the distribution of the resources for the users, and the quota, and the bills, the billing. As I told you before, the data layer is the layer that takes into account the, let's say, the retrieval of the data from the data providers. Here you see just a quick look to do some of the data that are available in the Atom platform. And as I said in the initial slides, there is the possibility to have in the same platform data that are product data that are coming from different sources. So, for example, you see products from the Copernicus Sentinel, so typical satellite mission, but there are also data from, let's say, climate projections and from weather forecast providers. As I said before, Adam provides different ways to access the data. There is a human-friendly interface that is the Explorer, where the user, the generic user, can enter and explore two-dimensional or three-dimensional virtual globe. It depends on the need, and the globe can be visualized with different projection, and it is possible also to visualize a terrain elevation service for, let's say, needs of visualization. This is, let's say, a manual approach to the data access. For scientists, for experts who need to work with data to make some advanced processing, it is available a Jupyter instance where the data can be retrieved with the specific functionalities. And on this instance, the user has an independent environment where he can produce his own script or import scripts from other, and reproduce, for example, algorithms or processings that have been already, let's say, tested outside out of the own instance. For software developers, it is also available a machine-to-machine approach that can use the available APIs or an OGC interface. During the life of other platform, various applications of the other platforms have been developed for different use cases, and I will show just a few of them, some that can be more representative, and I will start, let's say, with a simple demo of the Adam Explorer, so for the basic functionalities of the original platform. I'm now shifting to the platform. Can you see it?
Yes.
Yes, Antonio.
Okay. So this is the, let's say, the visual representation of the globe that is inside the Adam platform, and the user lands on the platform after the registration, or even in let's say in subsequent sessions. The globe, as I said, is a fully explorable, so the user can zoom in or zoom out and go around the globe where he wants to, let's say, visualize the data of interest. There is the possibility. There are three main menus. The one on the right is the one that allows to change the projection. So here we are on the trade view mode. And for example, if we zoom in, we can, for example, enable the 3D representation with the digital elevation mode. But there is also a possibility to change on the 2D representation. This is the equirectangular, there is a Mercator, and there is also the possibility to visualize the projection on North Pole and South Pole, depending on, for example, where the data are located. And also, sorry. Okay. And also, in case of particular needs, it's possible to change the base map. So here we have a base map with the administrative borders, and let's say similar like OpenStreetMap, so you can zoom in and see cities and locations, or something that is more similar to let's say Blue Marble, so let's say a another world view style. While going to trying to access the data can be accessed from the menu on the lower left here. As I'm using my own account, there is already some data sets that have been, let's say, used in the past and that are still in the bucket of the used data sets. If I would like to add another data set from the general catalog, I should go into press this button, and then the full catalog will be open. Here the user can scroll, can see which are the product available, and for each product there is a section of information that provides, let's say, the information about spatial resolution, the temporal coverage, and a description, let's say, of the dataset itself. When a user wants to activate one of the datasets that are available, he has to click on the, let's say, on the dataset he wants. In this case, I can choose the CAMS European Air Quality PM10. You see a bar that begins to move, and it's loading the data on the globe. You can see that the full product has been loaded on the globe. So this is a product that it is strictly covering the European region. So we have it has been loaded the full product, and we can see that a temporal bar has appeared on the lower right, and usually the product visualized is the most recent available. So in this case, as the CAMs are forecast, so our prediction, we are some days ahead to the current days, and we are seeing the 19th of February. Here we see the full product. The menu, the dataset menu, allows the user to play with the maximum and minimum of the dataset. So the user could, for example, saturate more the data while putting a lower maximum here. Or you could change the color map. There is a long list of color maps available that can be used. And then let's say this is still a traditional way of interacting with the data. What gives value to the ADAM approach, to the data cube approach, is the possibility to subset directly the data, this product, without being forced to download for the user the full product so on the full European region. For example, here in this menu on the upper left, this is the geometry menu, and there are different ways to, let's say, to draw a polygon, to draw a bounding box on the product. The user can draw a rectangle, so a rectangular bounding box, an arbitrary polygon here, or he can upload a polygon or a country borders, or something else from its own machine, from the local machine. For example, if I would like to upload, let's say, the country border of Italy from my machine, I could click here, select the polygon I want to upload. The file has been uploaded, and the user has just to, let's say, confirm the changes, the new polygon that is being uploaded. At this point, the polygon appears in the menu, and it has to be activated in order to actually provide the subsetting operation. On the lower menu, we can see the processing, so the subsetting operation that is ongoing. And in a few seconds, we get let's say, the product that has been subsetting only inside the selected polygon. You can see that on the upper corner of the right corner of the screen, the image of the subset has appeared, so the product is ready, and the user could download the product with this button. What we get is a zipped file where the user will find a GeoTIFF file representing the data that has been extracted. So it's a big advantage to be able to get directly the data of a single polygon from a single region without being, let's say, forced to get the full data on the local machine and then getting what it is really needed in the local machine. With the same, let's say, technological approach, another possibility is to extract a time series at a pixel level. In this case, we could, for example, change the base map, search, for example, for the location of Milan here. When we wanted to select extract a time series, so we have to give the point, the coordinates of the point to the system. We should click on this button, and that is described as draw point. Then we select the point on the screen, on the map. And the time series extraction starts. We will see some points appearing. What we could do is to select the map and, for example, here select which days we want to see. For example, if we want to see just one days, or the time series representing 2 days. this menu allows the user to let's say to choose how many days and the temporal coverage of the time series. We have to take into account that the CAMS data are hourly data, so each day you see 24 points, and so for 2 days we have 48 points. In this case, we only took 1 day, so we have 24 points for the single day. And at this point, we have the user has 2 options. He can just get an image of the plot, so saving this plot as a PNG file, or if he needs to work actually with the data, he can download the data as a CSV file. So there will be a download operation, and if we go to to this one, you will find here a zip file that can be then unzipped. Here it's made again a zip file with the name of the data. This is the other one. It is still working, so it is not ready yet. But we will get the CSV file, and it will be possible to work with the data as a list of values with the temporal references, and using, for example, uploading it on a Jupyter instance or inside the local machine. So let's say this is the basic usage of the dataset of the platform, and the important thing is that as what has been done for the CAMS, this particular dataset for the CAMS dataset can be reproduced for all the products that are inside the menu. So all this data can be used in the same way. We can activate one product, extract polygons if needed, or extract time series on a pixel scale. Now back to the use cases. Here we have seen the usage of the platform, let's say, in a manual way. What can be done? What has been done instead in the case of the ESA PDGS data cube is a bit different. The ESA PDGS data cube has been, let's say, has been designed in the same way of the ADAM platform. So the SAPGS Data Cube provides a visual interface where the user can access the datasets made available from the payload data ground segment of ESA. And of course, with this approach, there is also the possibility to use the data entering into the Jupyter instance, using the data as a scientist would do. On this usage, on this kind of application, we have been working during in the framework of the CEOs. Yes.
Okay, perfect. I just want to tell you to get back to the presentation mode. It's perfect now.
Okay, sorry. I was thinking that in the framework of the CEOs activity, we have developed Jupyter notebooks for the capacity development webinar, and in these webinars we showed which are the advantages of the, let's say, the data cube approach using the Jupyter notebooks. So using the data on a scientific way. And let's say this first case is something that I've already shown to you during the live demo of the Adam platform, because I showed you that thanks using the data in the Adam platform, we can directly extract the data at a country level, and then we will be able to work on the just on the country level data. And that would be, of course, the advantage of using the data only on a specific polygon is, let's say, even bigger if you have to work to do it on a time series. So when you extract data over Italy for more than one day, for months or weeks or years, doing it only over Italy or doing it for the full product is a consistent difference of computational times and computational power. And in this case, we have seen that it is possible to extract, let's say, we saw it manually, the data over Italy. What I want to show you a bit more in detail is the second part. So just not extracting the data for a time series, but adding some processing on it, and in particular to process the data and obtain what we call change map, or let's better to say anomaly maps. And we did it with the most data that are available on the PGS data cube. And now I'm going to show you the notebook that did it. So this is the Jupyter instance that is available in the PDGS data cube, and that can be used for the by the users getting the data directly from the let's say the PDGS data cube. This is the here it is where the all the Python packages are imported, and there is also the a specific package that works to interface the data, the Adam technology with the data provided by the ETA PDGS. Here we have the specifics of the data we want. So we indicate which is the endpoint, where to take the data from. So which is the let's say the data access service that will give the data, will make available the data for the user. We specify the name of the data set, and this is the soil moisture from SMOS. We specify the temporal coverage. And we specify, in this case, again, the geometry, because we are going to work directly on the data extracted on the at a level country. This is the function that will extract the data on a level country. Here the operation starts, so I could try even to run the whole process. So the data are step by step extracted month by month, day by day in the month of January for the year 2020 and 2019, 2019, and then 2020. It will take some minutes, but it will be considerably less than the let's say the approach that would be traditionally used. So getting the full data and then computing the average values and then computing the anomalies. And if we go down, we'll see which are the operations that are done. We will see then changing this year from 2019 to 2020. So we are getting now the second of the 2 years that are taken into account. And of course, we should do the same operation for the year that we want to compute the anomaly. So for the 2021, once that this processing has been is finished. The important thing is that, of course, all these computations are made on the cloud, so the user should not download anything on his local machine. Everything is done remotely, and in the end, he can just download the final result. Okay, so this is the time that is being needed to let's say, compute the average values just on the country level of Italy. Here we go with the computation of the averages. Here, and I don't do it, I will not do it because it is going to do the same operation, but just for 1 year that has been above. So here we compute the average, we extract the data for the January 2021. Here we computed the in the average. Here we computed the variation, so the anomaly. We get the result. Here the total time that is needed for the let's say with the data cube approach. There is also the creation of the file, the GeoTIFF, that then can be downloaded by the user. And here we have also the visualization of the anomaly map with the relative legend. This was the activity for the CEO's webinar was wider, so we had also to provide the let's say the notebook for the traditional approaches, showing let's say the difference in time for the different approaches. And what we saw is that using the data cube approach, so using the Adam technology, the time needed was about 6 minutes. Using the traditional approach, so getting the original data, processing, getting the country data, and processing the country data will require 30 let's say half an hour. Our approach will save more or less 80% of the original time. So this is one of the key point to take into account when we wanted to use the data cube approach. So using the technology implemented in the other platform. Last case that I would like you to show is a slightly different one. It is called it's the application, let's say the implementation of the ADA technology into the DTA hydrology. DTA stands for Digital Twin Earth, and let's say it has been applied as a market application regarding hydrology. And on this side, various use cases have been developed using the ADA technology. I will show you two of those cases. So I'm going to show you now. This is called the what if scenario for flood risk assessment, and the other technology, as you can see, is already shows something familiar. This is the global visualization, but in this case, the important thing is that the ADAM technology has been useful because for the flood risk assessment, multiple data sets have been used at the same times. And in this case, we have soil moisture mean and the precipitation mean. You can see these data sets represented on the globe. The lower one is soil moisture, and the upper one is the precipitation. And the use, let's say, the use of this what if scenario is that you can evaluate the flood risk assessment of 6 different stations located in the Po Rivers basin. And the flood risk assessment of these stations can change if you change the thresholds of the soil moisture mean and the precipitation mean. So there is a processing behind that computer that is able to evaluate the discharge that each station would see when the user changed these two values. For example, if in this case, with this initial configuration, for these values, all the stations have the green color, so there is no risk of flood in this configuration. If I change the values, for example, going here to 0.6 and here to this one, and I save that, we can see that for some of the stations, the status change from green to yellow. So, for example, this station that is called, let's say, that is called Borgoforte, and it is displayed here. We have this kind of configuration. If we go to this one, that is Casale Monferrato, we see a different representation, a different, let's say, distribution of the discharge. Here we can zoom in here, and let's say the particular application is that you can see the values of the discharge on the point. So we are looking at the time series over this point. We see the time series of these discharge values during 1 month. So here we have a time series application using the ADAM technology for a thematic application of hydrology. The other application instead is the large-scale water balance assessment. This is slightly different because we don't go to see what happens for single stations, but we take into account what happens in specific areas. So as we said before, we saw before during the basic life of ADAM. So we have the polygon extraction and the time series extraction. Here we have a use case on DTI hydrology showing you what happened in specific areas and not in specific stations. For example, here it's already active the Po River basin. Here we can see the monthly statistics of 4 different data sets. So we have the precipitation, we have discharge, evapotranspiration, and soil moisture, and also the snow water equivalent. All of them having the statistics over this area. We could also see, for example, the aggregation, the spatial aggregation of this data set of this value looking at the monthly anomaly. So we have the monthly anomaly from 2015 to 2022 for all these data sets. So the processing behind this is that the values have been averaged spatially in the region of interest, and then there is a time series extraction from in this time range, in these 8 years of study. And these can be replicated in the same way for the other areas. For example, if we go here, of course, the statistics would change. Let's see. From here again to this one. There is a change of the statistics, and there is also the update of the monthly anomalies. And this happens, of course, also for the others. And that shows how it changes, how the water balance assessment change if we change the area of it, or the area of interest. And of course, this is done keeping together the four different data sets at the same time. So all that said, we have seen, let's say, three different use cases in which the Adam platform can be used. Not only the initial one that is a basic usage, but using the technology that is behind the Explorer, we can, let's say, apply the Adam technology to different cases, and for different needs of the users. Can be thematic as the DTI hydrology, so for just for a subset of a dataset, or can be in the same way as the Atom Explorer, but with different datasets, as it has been shown with the PGGS data cube. And yes, that's all. And thanks for your attention.
Thanks a lot, Antonio. Thank you. Let's see if we have any questions in the chat. So participant is asking if it's possible to have the access.
Oh, sorry, I forgot one part. Sorry. There should be also the part to see how to register to enter, actually to start to use the platform, how to log in.
Okay, so if you can walk us through this.
Yeah.
Have a couple of minutes.
Yeah.
And in the meantime, actually, the participant is asking if it's possible to have access to the notebook related to the use case you presented for
okay.
soil moisture using PGD.
I think I'm not sure, Simone, if there is it is published from the CEOs.
Yes, these have been published through CEOs, but users can also access those notebook connecting to the European Space Agency instance. So I'll share in the chat the link in a while.
Okay. I think the participant shared the link that he found.
Yeah.
If you confirm that it's the right one.
Yeah. So just a few minutes to see how to get to enter to register to the platform. Here you can see the URL that the user can use, where the user can go to see what is Adam platform, to have more information about the platform, and actually to go to the registration page. This is what I'm going to do now. So here it's the landing page for the users. If the user wants to see more details, this is the full description of what is available and what can be done. The user can enter here. And this is let's say the landing page of the platform, but of course for the first usage it is necessary to log in. If I am a new user, I should go to register new account and provide some details. So I can just doing it by myself quickly. you just can provide the mandatory informations. You save your information. Then you should receive an authentication email in a few seconds. If I try to go to my email, I should get an email here. Let's see. Okay, so you get an email from with this object, and also check if you don't see anything. Also check in the spam folder if something could have arrived there. You open the email and you find this link. You go to this link. The authentication is done. You should choose your password. You confirm the password. Okay, so we said that the password has been successfully reset. At this point, we can really go to the sign in. Sorry, now we can really try to do this one. I can go back to the other section. Here. Okay, now you can try to get to log in with the new account. You can enter, and once you enter, you get your instance. You get your username and your password. You can begin to play with the platform. Here there will be an empty bucket of data set, and you have to go to the general catalog to edit, to add new products, and here you will have, of course, no element here to be empty, and you will have to create your new polygons or to upload new polygons, and then you can begin to play with the platform.
Perfect, thanks a lot. So the participant actually confirmed he can access the notebook.
Okay.
And as you said, Simone, if the person does not have an ISA account, there is a sign-up procedure that allows them to access it. That's great, perfect. I have one quick question. Can a user bring his own data to his, as a developer, for example, to his workspace environment and then to the platform to build his application, or not?
Not, let's say, if you want if you are in the Jupyter environment, you want to upload some data to work with the data and let's say integrate your data with what you have taken from the Adam catalog. Yes, if you want to upload the data into the platform directly in the user interface, that is not possible. Let's say in an easy way. I think. There is some more steps to be done, and that's maybe where Simone has to come. The managers have to come into the let's say the maintainers of the platform.
We do have initiatives. We are working with ESA and NASA, where we do provide to scientists an API to bring their data into the platform as well. But being this an experimental and new feature is not exposed to the, let's say, standard user yet. Okay,
thank you. So if we have no further questions, I will hand it over to you, Federico, for the NOR portal. We have a couple of minutes and to present the sponsorship process. Thanks, Simone and Antonio.
Thank you, Zainab. Thank you, Simone, and thank you, Antonio, for your presentation. I'm quickly going to share my screen and present the NOR portal. Okay, I think you can see it. So to access the network of resources, you need to navigate to the web address nor-discover.org, and you will be redirected to the homepage of the Network of Resources initiative. Then here you can see some useful details about what is the network of resources, the number of approved projects, the number of providers onboarded, and other useful information. You can also navigate through the different pages of the NOR portal. For instance, you can go on the news section where there are some news related to the NOR, or you can go to the portfolio, that is the catalog of all the different services that are available through the network of resources. By going down on the page and accessing the portfolio, you will be redirected to a new web page where there is the actual catalog of all the different providers and all the different resources. You can navigate with a text search or by selecting the service types and so on, or you can just scroll down here the entire portfolio. Let's say we want to access Adam, so when we find our provider and the services we want to request, we can check some details related to the provider, the collections available through the specific platform, the provider help desk link. This is really helpful because it allows you to contact the provider and understand if the services that you are looking for are really helpful for your project. And then once you have all the information, you can go to the pricing wizard to ask for the specific resources. The first thing that you need to do is to select the project type you're working on, if it's a commercial, research, pre-commercial, or educational project. We want to remind you that only research, pre-commercial, and educational projects are eligible for ESA sponsorship. So let's say we are working on a research project. And here we can select by clicking the tick box and by changing the units and the duration, the different services that we want to request. So we can select multiple services and we can then go down to the page and have an overview of the total cost requested and two different possibilities. The first one is to purchase the services directly from the provider by going to the provider website, or you can ask ESA for sponsorship. And there are some eligibility criteria that need to be filled to ask ESA for sponsorship. First, you need to select if you're working for an ESA project or not. If you're working for an ESA project, you need to have, of course, an official ESA contract with a contract number and a technical officer that who follows your project. Let's say we are not working for an ESA project, and then you can decide to co-found or not the cost. Let's say we are not co-founding the cost. Then we click Ask ESA for sponsorship. We'll be redirected to a new web page where we need to fill out all the fields with the relevant information, starting from the project title, our name of the project coordinator, our work category, our email address that must be an organization email address. We cannot accept personal email addresses. A project or organization name, country, web page, and address. And then you can fill out all the relevant information related to the project objectives, the methodology that you're going to implement to reach these objectives, the expected results, the justification for the selected service and provider. And this is why we advise you to contact first the provider in order to fill out this field with a justification that tells us why you are going to request specific services. The description of work within the cloud environment that you are going to do. We want to remind you that the Network of Resources is an ESA initiative that aims to bring user to data and not the contrary. So we want to see that you are going to work within the cloud environment of the provider. The geographical area of interest of the project, if you're working over countries, cities, and so on. And then you need to select if it's the first time or not that you have applied for NOR. If it's not the first time, you will have to put here the previous request ID. Then you will have an overview of the resources that you are requesting. And the last thing that you need to do is to fill out the expected date of submission of the set of slides in the form of month and year. The set of slides is a set of 5 PowerPoint or PowerPoint-like slides where you provide let's say, an explanation of what did you do with the services that you requested through the network of resources and how these services were helpful for your project, even if you didn't reach your final goal. We want to see that and how you use that resources. Then you can or cannot sign up for the NOR newsletter, and you must accept the ESA privacy policy. Once you have done all of this, you can export the sponsoring request. It will create a PDF file. You need to download the PDF file, sign it, and if you're working on an ESA project, you need to have also signed it by the ESA technical officer, and then mail it to the NOR-sponsorship-request at ESA.int. This will start the evaluation procedure that usually takes around 6 working days, but it might take longer if we need more information. In that case, you will be contacted to ask more information about the project. This ends my part, so I give it back to you, Zana. Thank you.
Thanks, Federico. So I just put the link for the NOR portal in the chat. Feel free to explore it and send to us if you have any questions concerning the sponsorship process. We're running a bit out of time, so thank you so much, Antonio and Simone, for the nice presentation about Adam platform. And thanks to the participants. Again, feel free to reach out to us if you have any questions, or to Antonio and Simone if you have questions about the Adam platform. And we hope to see you in another training session very soon. Thank you.
Thank you. Bye.
Thank you. Bye.